Hello chemists, I'm going to take you through identifying an organic compound from the three spectrographic graphs we have been studying so far. As you can see, we have all three graphs here. We do not know what the compound we're looking at yet is. However, based on our knowledge about these graphs, we can start putting some information together. It's a little bit overwhelming to start with these three graphs and no more information than that, but you can use your skills to identify the compound. You will jump around from graph to graph, backwards and forwards, and eventually you will be able to figure out what it is, and with some checking, be pretty confident of your answer. So I usually like to start with the 13C NMR just because it's nice and straightforward. The information that we get from here is that there are two peaks on this graph, which means there are two carbon environments. This third peak here called solvent, that peak is ignored because it is the solvent that the compound is dissolved in when they did the 13C NMR spectrographic analysis. If you ever see a peak labeled solvent, ignore it. Doesn't even count. This is a two carbon environment 13C NMR compound. Okay, so we know we've got two carbon environments. Now I want to jump over to the mass spec. From the mass spec, I can see that my molecular ion peak right here, has got a M to Z ratio of 60, which means that the mass of the whole compound is 60. So that is a good thing to note down. And then I'm going to leave this graph. I've gotten what I need from it for the moment. Then we come back here and we start looking at what sorts of peaks we can see on this graph. I usually like to check for four types of peaks first. That's nitrogen, C double bond O, O to H, and C to H. Check just whether those are present or not. You should already have a hint about whether nitrogen is going to be present or not from this graph, remembering that if your molecular ion M to Z ratio and mass is even, you do not have a nitrogen present. If it's odd, you might, depending on whether you have a haloalkane or not. So over here, we can look just in case for a nitrogen peak. We've got some peaks that might be nitrogen, but our mass to charge ratio from the other graph argues against it. I also see this peak here. This peak here could be a couple of things. It could be an aldehyde, it could be a ketone, it could be a carboxylic acid C double bond O, or an ester C double bond O. We can ignore the ester bit for the moment. So it could be any of those three things. The way we can figure out which one of those three things it is by looking at the rest of the graph. Over here, I see this really characteristic broad medium strength peak, which is very characteristic of O to H. O to H, so that would indicate to me that there's O to H present. That O to H, the presence of that O to H tells me that I'm not dealing with an aldehyde or a ketone, because aldehydes and ketones do not have O to H bonds present in them, so it must be carboxylic acid. Therefore, I know that there's a strong narrow peak at 1705 to 1720, which is the C double bond O. I know there's a broad medium strength peak at, broad medium strength peak at 2500 to 3300, which is the O to H. We also know that there's a C to H bond in here that is often covered up by the O to H, but we know that that peak is there as well. It should be in the 2850 to 3000 range. It's there because pretty much any organic molecule is going to have a C to H, so we definitely expect to see a bond there. Those are the only bonds that I recognize in this graph, remembering that the fingerprint region is anything to the right of 1500, anything below 1500, and that is all ignored. All right, so far I know that I have a molecule with two carbon environments. It has got a total mass of 60, and it's got an O to H bond, a C double bond O, and some C to H present. So I know that in my molecule I'm going to have two oxygens present, one from this bond here and one from this bond here. That's already a mass of 32 from those two oxygens, 16 each. I know because I have 2 carbon environments, that I'm going to have at least 2 carbons. Knowing that half of my mass is already taken up by those 2 oxygens, I can see that I could have at most probably 3 carbons in order for the number of carbon environments to match the mass. With a little bit of math and a few sketching of molecules, I can see that if I have 2 carbons, one of them with the carboxylic acid functional group and the other one with 3 hydrogens on it, that will give me my mass of 60, telling me that my molecule is ethanoic acid. It's got 2 carbon environments. It's got a C double bond O. It's got an O to H and a C to H bond. Now that I have my proposed structure for the molecule, I can start looking for fragments and see whether those fragment peaks appear in the mass spec graph. I know that this fragment here is going to have a mass of 45. So I would expect to see a peak at around 45 m to z. I know that this fragment here has got a mass of around 15, so I would expect to see a peak at around 15. I know that this bond could possibly break, which would give me a mass of whatever the whole thing minus 17 is. 60 minus 17 is 43, so I may see a peak around 43 as well. So if I flip back over to the mass spec graph, I can see my peak at 45, 41, 2, 3, 4, 5. There's my peak at 45. I can see a peak at 15 right here. I can see a peak at 43, 1, 2, 3. That's this base peak here. It's the whole thing minus a hydroxide. And that is all the peaks I need to identify to kind of clinch the fact that I am dealing with an ethanoic acid. So kind of you go from graph to graph, pulling the useful bits of information from all of them, and then when you have gotten all the information that you need to make a possible identification, then you go back and start identifying fragments. The things used to check your work are the number of carbon environments present from the 13C NMR graph, and also the mass and possible fragments from your proposed structure in the mass spec graph. In our next video, we will spend a little bit of time going over how to write that up.